Let's try this again. How's it? Can you hear me now? All right. I was muted. Sorry about that. Um, so because there's no class on, no school on Monday, cohort A, odd hours will meet Tuesday. Cohort A, even hours will meet Wednesday. So there'll be no office hours next week on Wednesday. And then the cohort B classes stay the same. So Thursday would be the odd hours, Friday next week will be the even hours. If you have questions, if you need help, please still reach out, send me a message, send me an email, whatever way works best for you. Um, and I will answer those as soon as I can. Usually I answer them. If I'm not in class, I'll answer it right away. Um, I do have afternoons pretty open. So if you need, if you want a Zoom session, let me know. And I can certainly set that up after about 12:30 or so is usually when I have time. So if that works, let me, again, let me know. All right. Questions about any of that? All right. Then let's get set and get going on today's stuff. So the last three classes, we've talked about solving systems by graphing, solving systems using substitution, and solving systems using elimination. Um, to be honest, when you come across these problems, it's not going to say solve this system with this method. So today we're going to look at, which method is best when. So that's what today is going to be about. All right. So you can solve systems of linear equations using a graph, the substitution method, or the elimination method. The best method to use depends on the forms of the given equations and how precise the solution should be. So to solve by graphing, my suggestion would be to use only if both equations are in slope-intercept form. So if they're both in that y equals mx plus b form, graphing would make sense. The other thing I would say is after you graph, if the solutions don't come up at exact points, you might want to try a different method. For substitution, use when one equation is solved for a variable. So it's either in the x equals or y equals form. And then for elimination, it's best to use when you have a variable with coefficients that are opposites, right? Then you just add the equations together and it eliminates one variable. However, it would also be the method if it's not convenient to graph or use substitution. So elimination is kind of the catch-all. It can be used with just about any um, system. There are just times when it's not the most effective. All right. So what we're going to do, for example, one, the three systems, you're just going to decide which method you're going to use to solve the system. You're not actually going to solve it, just what method would you use? And what I'm going to do is I'll put up a poll, and you can just click on whichever method you would think. So looking at system for A, I thought I had it set up, but I guess I didn't. All right. So let's see if that worked. There we go. All right. So for system A, which method would you choose? Would you use? Select either graphing, substitution, or elimination. All right, still looking for 2 votes. All right. So for this one, the most popular choice was substitution. So I'm going to ask, if you chose substitution, can you just put in the chat or unmute yourself and just tell me why substitution for letter A?
Because the X and Y are lined up with other things, problems.
Okay. Okay. So let's just go back one slide real quick. And for substitution, it says we should have the X or Y by itself in one of the equations. So if I go back to A, they are lined up. That's correct. I think we talked about that with elimination. We wanted to line up the X's and the Y's. And I'm not saying that substitution wouldn't work. In order to use substitution, we would have to solve either the first equation or the second equation for one of our variables. So, and likewise, yep, I could graph it, but the way that it is right now, there's going to be more work if I chose to do substitution or graphing. Not saying that there isn't any work to do if we use elimination, but there's probably a little less work. All right, let's try letter B. So which method would you use to solve system B? One more voter out there. All right, so for the system in letter B, by vote, the most popular was substitution. And in this case, we do have one equation solved for x. So we could take that 2y minus 4 and substitute it into the first equation and solve. So I would agree with that one. Substitution would work best the way it's set up. Again, that doesn't mean that you couldn't use graphing and you couldn't use elimination. You would just have to do a little bit of work for each of those methods. All right, letter C, the last one. So again, which method would you use for the system in letter C? All right, very quick vote that time, like it. And by a large majority, this one came up as graphing. And the other vote was elimination, which definitely you could multiply one of those equations by -1 and add and use elimination. That would work. So either of those actually are good choices for letter C. You could also use, you could also say, well, I think substitution, because I do have those equations in a y equals form. So really not a wrong answer for letters and not a wrong answer for any of them. Um, However, if we use that criteria from the previous page, they're both in slope intercept form. So graphing would be the way to go. So what I usually do is I look at my system and I just work down, I look, are they both in slope intercept form? Y equals mx plus b. If so, graphing. Then if not, is one of them in x equals or y equals form? If that works, then substitution. And if that's not the case, then I know elimination right away is the preferred method, or probably the most efficient, the easiest method. All right. So now we're gonna choose a method to solve, and then we're gonna solve the system. So again, I'm still gonna use the polling. So tell me which method you think, and I will go with the most popular answer, and we will solve it whatever way that method comes up. All right, all votes are in, and barely substitution is the winner. So we will use substitution. And I like substitution in this case because we do have that one equation in x equals form. So I'm going to take y minus 16, substitute that in for x. Excuse me. Then we distribute. Multiply 10 by both of those things in the parentheses. We have y's on the same side of the equal sign, so I can combine the 10y plus 9y. Add 160 to both sides. Divide by 19. And again, that's one I would probably use a calculator for. But 171 divided by 19 is 9. And now that I have my y value, I can plug that in. I'll plug it into that second equation to find my x value. So I get negative 7, 9. And if I wanted to double check that, I could plug into the first equation and check. Now, it doesn't say I need to check, but again, with systems, you can. And then you'll know if your answer works or not. So in this case, I get negative 70 plus 81. Does that equal 11? And it does. So there's my solution with a check. Right. Next example. Again, I have you vote. Which method would you choose to solve system B? Three more votes. Two more votes. Polls close in 5 seconds. All right, so for this one, the most popular choice was elimination. Now, to be honest, I would probably not use elimination. I'll show it with elimination. I would probably choose graphing. But as I said, I will go by the most popular choice. So I'll show it with elimination. I'll also show it with graphing. So in this case, my y's have the exact same coefficient. Excuse me. So if I multiply the bottom equation by -1, I can eliminate the y's. Negative y equals x plus 3. So we get 0, negative 3x. Remember, there's like a 1 here, plus 9. Add the 3x to both sides. And divide by 3. So this would be if you use elimination. One of the things that can cause problems that some students have an issue with is getting that 0. But if you're using elimination, that's what's going to happen. If I then plug into the top equation to find my y value, so I have my solution, 3, -6. Right? That's using elimination. If I use graphing, my top equation has a y-intercept at 6 and a slope of -4. Looks something like that. Pretty close anyway. And my second equation has a y-intercept of -3 and a slope of -1. There we go. Try to fix these graphs a little bit, and we can see the point of intersection appears to be down there at 3. Whoops. At 3, -6. So again, we get the same answer, both methods, which is good. We should get the same answer. It just becomes the question of which you're more comfortable with and which is maybe more efficient. And this graph is just not, there we go. That looks better. All right. Third example. All right, which method would you use to solve that system? All right, 3 more people to vote. Two more people to vote. And 5, 4, 3, 2, 1, end the polling. All right, so this one came up as elimination. So if I'm going to use elimination, the first thing I want to look for, do I have exactly opposite coefficients? And I don't have exactly opposites. Can I multiply to get opposites? Well, if I look at my second equation, if I take that 3 and multiply by 2, I'll get an opposite there. I'll have positive 6x, which would be the opposite of the negative 6x in the top equation. So I can multiply my bottom equation by 2 and get opposites. And remember, you're going to multiply everything by 2. Because we have opposites, we're going to add. Negative 6x plus 6x, that's 0. Negative 10y plus 10y, that's 0. Negative, so I have 0 here. When we use elimination, if we get 0 on the left-hand side, usually means we're going to get either no solution or infinitely many solutions. In this case, it's 0 equals 0. So this is infinitely many solutions. All right. So what we're going to do next is I'm going to have you try a couple on your own, and then we'll take a look at those solutions. So here are the 2 I want you to try. Maybe. Oh, there we go. I'm going to give you about 5 minutes. Use any method you want. Find the solution for each one, and go ahead in the chat. Tell me what your solutions are. Excuse me. So I'm going to start the timer. I'm going to mute me, and that way you can work on your own.